One of the common uses for an electronic load is testing the reliability and capacity of batteries. Batteries can be tested under a variety of static and dynamic load conditions. Today we're going to talk about using the battery application test on the DL3000 series electronic load. We will analyze service life and capacity on a number of batteries and draw conclusions about each battery's capability and usefulness. Let's take a look at our test setup for one of our 18-volt lithium battery tests. Here we are with our DL3031A electronic load connected to an 18-volt lithium-ion tool battery. Let's first take a look at how we're going to set up this battery test. We hit the app button, go into battery mode. Let's set the current for a 1 amp constant current pull. Here we're going to use the V-stop to stop our test. Pretty common on a battery test to stop it at roughly half the voltage of the normal battery voltage. Here we're going to set 9 volts for our 18-volt battery. You can also set capacity limits in a milliamp hours or a time stop as well. The voltage on is an important one to remember. You want that to be lower than your normal battery voltage because the test will not start until it sees voltage above that. All right, let's go ahead and start this test. So we see the current ramp up to 1 amp and the voltage will start to draw down. In real time, we can also measure our capacity. Here we're going at about a milliamp hour every 3 or 4 seconds. And our timing as well is listed on the display. So these are all great values, important values for our battery test that we're going to record and use later when we're comparing results. Now let's look at another way to record that data. Start by opening the UltraLoad free software. From here, we can connect to the instrument over USB, LAN, GPIB, or RS-232. We see the 20 volts we're starting with. Since we're already set on the battery test, we can go ahead and hit the on button. Now we're running our battery test. The front panel of the instrument is showing milliamp hours, time, current, and voltage. We can see the voltage, current, and power here. We can also record this. Save a file on the desktop. So now we're logging that CSV data onto the PC in real time as we're taking samples from the instrument and conducting our test. So this battery test will stop when it's over and we'll have a complete time set of data including voltage, current, power, and resistance for all the points during that test. This is a great way to record your data for later analysis in addition to anything you might do visually in the front screen. Remember, you also have different ways to stop that test. We can stop it here remotely. In this case, we've programmed it automatically to stop at a certain voltage level, but it can also be programmed for capacity or time. Lastly, if we are working remotely, we can always open the virtual front panel, and then we can see exactly what we want on the front panel at any time. This is another great way to work with your load when it's in a test bay or a position that's hard to get to physically, or where you need to work remotely to analyze your data. After completing all of our tests on different batteries and compiling the results, we can see that the 18-volt batteries, P100 and P102, are both likely designed to operate between 1 amp and 2 amps of constant current load, as the tests show similar operating conditions under both of these tests. Clearly, the lithium batteries are in better condition. They show a much stronger curve with higher capacity and longer service life. As a side note, a similar test on a AA battery shows significantly less capacity under the higher load. A single AA battery is not meant to provide that much constant current. Now let's compare these results to the specifications for the batteries. Here we see that the nickel metal hydride batteries are only operating at about 15% of their specified capacity. This is largely due to their age and the charging cycles. Historically, nickel metal hydride batteries do not like to be left on the charger and being charged for long periods of time. It can limit their capacity. On the other hand, The lithium-ion batteries are still operating at about 75% of their listed capacity. These batteries simply hold capacity better and respond better to being charged consistently. These are just some of the battery characteristics you can test with a DL3000 series electronic load from Regal. We'd like to offer a special thanks to Malcolm Armstrong, who shared his data with us for this application as a beta tester for the Regal DL3000.